Welcome back, Algebra 2 students. Happy Monday, May 4th. I'm not going to make the Star Wars joke. We're going to start with a debrief of our warm-up here. So suppose you roll a six-sided die and then flip a coin. Are these events independent or dependent, and explain? Well, think about this for a moment. Does one of the events impact the probability of the other events? No, usually this takes place when we pull out a card or something and we don't replace it. That impacts the next probability of the event. That's not happening here, so these events are independent. And let's explain that. The coin flip does not impact the likelihood of the die roll, okay? So these are independent events. Now question B, part B, what is the probability of rolling an even number and the coin landing heads up? Okay, so we have two events here. Event A, let's define as rolling an even number. Okay, and let's think really quick. What's the probability of A? Well, how many even numbers do we have on a dice? We have 2, 4, and 6, so we have 3 out of the total of 6. So the probability of rolling an even number is 1 out of 2. And then event B, we have, let's see, where coin is heads. All right, that's the probability of that is 1 out of 2. There's only one way to get heads out of 2 possibilities. So the probability of A and B is, these are independent, so just straight up the probability of A times the probability of B. So 1/2 times 1/2. This is a 1 out of 4 chance that you would get an even number and landing a heads, or 25%. Okay, folks, it's kind of clear we're not going as in depth as we could if we were together, so we are moving on from chapter 10 and going into chapter 11. I think it's going to be our last chapter together. It will be on statistics. So let's start by taking some notes on 11.1. If you have a printer, go ahead and print this sheet out. You do not need to have a printer to follow along with us. You can just write some notes. You'll just need to draw these curves with us, okay? So let's start with defining some things. So in statistics, remember we're taking notes, we're moving along together. In statistics, very often data will be collected through observation maybe, or survey, okay? And the results will follow a normal distribution, okay? It's a big idea in statistics. We're going to spend a lot of time on it, talking about normal distributions today, all right? The graph of a normal distribution is a bell-shaped curve, kind of like we're seeing here on the right side. Okay, that is symmetrical about the mean. Okay, the mean being our average. All right. We're going to get to these graphs here, just defining some things. Now, a big idea, the standard deviation, we might have heard that before, this term standard deviation. The standard deviation is a measure of how far data is from the mean. Okay, standard deviation helps us measure how far we are from the mean. The mean for us, you can actually mark this on the first one, is always in the middle. Okay, and like I was saying, it's symmetrical. It's kind of a reflection on either side. So how about on all of these, we mark the mean value. Usually we'll write it, actually I'd write it right here. And I will do that on our examples, but I'm going to write something else right there through our notes. Okay. Now the standard deviation is kind of represented by these bars. It's we're going to talk about like the data that's away from the mean. Okay. And so we can use the standard deviation to identify what percentage of data lies where on the curve. Okay, what percentage of data lies where on the curve? So let's begin by looking at our first normal curve distribution. Okay, we don't have any context. Later we're going to talk about crocodiles, but here no context. We put the mean here in the center. The first thing I want you to think is that when we collect this data from wherever in the world and it falls in a normal curve distribution, 68% of the data lies within one standard deviation to the right and one standard deviation to the left. So in between this amount is 68% of the data collected. Okay, and I want you to label that, and then I want you to kind of shade it in like I am, or if you have nicer colored markers or something, maybe you would use that. 68% of our data is in here. So what does that mean? How much data is just in this part? Well, symmetrical is you can divide by 2. There would be 34% here. But 68% within one standard deviation from the mean. Okay. Now, let's go 2 standard deviations to the left and two standard deviations to the right. What percentage of data lies in this place? Okay. 95% of our data that we're collecting lies within 2 standard deviations. So go ahead and shade that in. Okay. 95% of the data is within 2 standard deviations to the right, 2 standard deviations to the left. That's a lot of our data, but you can see there's still a little bit extra here on the right and the left. So 3 standard deviations to the left and 3 standard deviations to the right has almost all of our data. Still there are some amount here on the left and the right. It's 99.7% of the data that lies within 3 standard deviations to the left and 3 to the right. So go ahead and shade that in some way. That's right here. We are not shading in this little bit, and this little bit ends right here. Okay, that's a common mistake. There's still a little bit left. How much is actually left here and here? Well, subtract from 100. We have 100% of our data under the curve. So there's 0.3% left here and here, and if you divide it by 2, this would be 0.15%, and also right here, 0.15%. Okay, and altogether, 100% of data under the curve. So something that's going to be helpful for you is what's coming up next. We're going to create another normal curve that breaks down the data, okay? I'm going to show you what I mean. So what I want you to do, and I'm going to do it too, carefully draw a line, give yourself a bell-shaped curve like that. It doesn't have to be perfect, okay? And right here in the center is the mean. And then go kind of evenly spaced, 3 bars to the right, and then 3 bars to the left, okay? And sorry, I want to title this a normal curve all broken down. What's coming up next is questions like, what percentage of crocodiles are longer than this amount? And we're going to be using normal curves to talk about what percentage of data lies within like certain amounts. So let's break it down. The first thing is, if I know that 68% is in between here and here, and it's symmetrical, then what percent is here? Well, these are even. I know I drew it, they don't look perfect, but they're even. So this is 34% of the data, and so is this. Okay, 34% here and 34% here. And then let's think, well, if 95% was here and here, we're going to focus on these two spaces now. So think about subtracting 95 minus 68. You know, I'm thinking about these spaces. Well, that would leave left over 27%, and I want to know each of these, so divide by 2. So in each of these pieces here, this is 13.5% of the data, and 13.5% of the data, okay? We're going to do the same thing for these two pieces. Let's think we're going to subtract 99.7 minus 95. So how much is left over in these pieces together? That would be 4.7%, and if you divided that by 2, we would have 2.35%. Okay, so in this piece is 2.35%, and so is this piece. All right, hang in there. This is going to make a lot more sense when we get a real example. And just as we showed before, what was this little edge piece? We already know that it's 0.15%, and over here the same, 0.15%. Okay? This is going to be very helpful. Think for one moment, take a step back after you filled this in, and think, if I was thinking what percent of the data is greater than the mean, this is half of our data, so greater than the mean is 50%. You have 50% of your data here on the right, and if you added up all these numbers, you would get that, okay? And similarly, you have 50% of data on the left that's lower than the mean. Okay, let's build up this understanding by trying an example. This is relatively true. The average length of a male saltwater crocodile is 17 feet with a standard deviation of 2.5 feet. Show this information on the normal curve distribution on the right. So we are always going to start with this by putting the mean down. Well, where does the mean go? It should go right here. So 17 feet is the average length of our saltwater crocodile. All right, it's very big. With a standard deviation of 2.5 feet. So if I'm going up a standard deviation, I'm going to add 2.5. So here is 19.5. And if I'm going up another standard deviation, I'm going to add another 2.5. So this will be, what do we got? 22. And if I go up one more, again, I'm going to add another standard deviation, so 24.5. You want to do this carefully. If we end up making a mistake on this, it'll be hard to answer the questions. Now, if we want to go to the left, what do you think we're going to do? You guessed it, subtract the standard deviation. Okay, so here we're going to have 14.5 feet. Okay, and going to the left once more, subtract 2.5 again. So here is 12, and then one more standard deviation to the left, subtract 2.5, and here is a 9.5. All right. So we did part A. We showed this on the normal curve. We have our average in the middle. So think about this for a moment. Let's just try to connect it to the notes that we just saw. 68% of our crocodiles are in between 14.5 feet long and 19.5 feet long. All right. 95% of saltwater crocodiles are longer than 12 feet here and less than 22 feet. And 99.7%, pretty much all saltwater crocodiles, are longer than 9.5 and shorter than 24.5. Okay. If this is still weird, let's try to answer this question. What percentage of male salties, real word, are longer than 19.5 feet? Show your understanding by shading this region on the normal curve distribution. Okay, longer than 19.5. Here is 19.5. Usually if it has a question and it has a number there and we don't see it here, we might have done our standard deviation wrong. But here we got 19.5 is right here. And we're talking about longer than. So we're going which way? Not shorter, longer than. So here on the right-hand side, all the way up, okay? Even this little bit too. So shade in that region. And then what percentage? Well, this is why we broke it down. This is true if we ever have a normal distribution, it's going to be using this. And so we have 13, we're starting here. So we have 13.5, and then we have 2.35, and we have 0.5. And what does that total up to? That is going to be 13.5 plus 2.5. We have 16, okay? 16% of saltwater crocodiles are, I'm sorry, you couldn't see that. So we added this up. We had 13.5, 2.35, 0.15. We add those up. 16% of the data, or 16% of saltwater crocodiles, are longer than 19.5. All right. Another way of approaching this is we know that 50% of the crocodiles are greater than the average. Okay. So, and we know that 34% of the data lies within here. So you can think about 50% minus 34%. That's another way of seeing the 16%. Okay. Folks, we have an assignment here that's going to focus on this. Go slow. Start by always writing in your average, and then the standard deviations up by adding, down by subtracting. And we have office hours on Thursday now every week from 12 to 1. And I want to see you there if you have any questions, or email me your questions or remind me them. Okay, folks, keep up the hard work. We have 3 more weeks. We can do this. All right, I will see you on Thursday.